Okay, welcome to the second half of part two of our lecture video series from Monday. Nope, it's April, April 3rd, where we continue discussing different definitions that we have for what a base is. Namely, now we are looking at the definitions that describe what bases do in chemical reactions. So not just what bases are in terms of what they contribute to solution, but what bases actually do once they react with something else. So let's start with the Bronsted-Lowry definition. So you might recall from our previous video that the Bronsted-Lowry definition of an acid says that an acid is anything that donates a hydrogen ion or an acidic proton to something else during reaction. So similarly, we've got the Bronsted-Lowry definition of a base, which states that a base is any substance that accepts hydrogen ions or acidic protons in reaction. So bases accept hydrogen ions in reaction. So if we look back at our reaction of, I believe we had sodium hydroxide and hydrochloric acid, we found that this makes liquid water, which I'm writing as HOH. This is from our double displacement, where we had the OH and the H, and the Cl and the Na doing our double displacement, forming HOH, and then aqueous NaCl. And if I were to write our net ionic equation for this, we would again see H plus OH minus, forming HOH, where in particular, because we had the acidic proton donated, that means that the hydroxide accepts H plus, which is what makes this the Bronsted-Lowry base. And if we're looking at this from a Lewis perspective, which is not looking at our acidic proton, but rather what our electrons are doing, then we see a similar kind of inverted definition compared to an acid, where remember a Lewis acid is an electron pair acceptor. In a Lewis base, bases are electron pair donors, meaning these are the substances that are the source of the electron pair that forms our coordinate covalent bond. Another way to say this is these are nucleophiles. So nucleo meaning like nucleus, meaning positive charge, lovers. So if we go back to our example where we looked at the reaction of boron tetrafluoride with ammonia, to form this thing that I demonstrated I already cannot name. We see that because we have the electron pair here that is being donated to the BF3, creating this coordinate covalent bond, this is what makes the ammonia the Lewis base. So what bases do in reaction is they either accept acidic protons or they donate electron pairs. Again, this is going to be our main focus. Namely, can you identify a base according to whether or not it puts or contributes hydroxide into solution? So that's our Arrhenius definition. Or can you describe what bases do in reaction, and that is accept some kind of acidic proton from an acid? So just like in our acid definitions, we're going to focus mainly in 210 on the Arrhenius and Bronsted-Lowry definitions, though your Lewis definition will pop up again in 220 and again in your OChem classes. So in our next video, we are going to discuss what happens when we have an acid and a base come together, a process called neutralization. And we've already actually looked at some neutralization examples in discussing the different definitions that we have for acids and bases. However, let's go ahead and give a formal description of what a neutralization reaction is, and let's also write out our net ionic equation and complete ionic equation for various neutralization reaction examples. So that'll be coming up in our third video, which is soon.